Hey everyone, and welcome back to the podcast. I'm Mark, and as always, I'm here with Jenny, ready to dive into another fascinating corner of the tech world.
Hey Mark. Super excited for today's topic. We're talking about something that, honestly, I thought was still firmly in the realm of science fiction. AI-powered smart checkout systems, but it's real, and it's happening time now.
It is, and this isn't just some incremental improvement either. We're going deep on this collaboration between MulticoreWare and AMD. They showcased this thing at Embedded World 2025, and, well, it's pretty impressive. Think real-time shoplifting detection, all thanks to the magic of, wait for it, generative AI and edge computing.
Okay, hold on. Generative AI times edge computing? You're throwing some big terms around. Let's break that down a bit. For anyone who's not familiar, edge computing, in simple terms, means processing data closer to where it's generated, right? Instead of sending everything to the cloud?
Exactly. Think of it like this. You have all these cameras and sensors in the store, collecting massive amounts of data. Sending all of that times to the cloud for processing would create a huge bottleneck, not to mention latency issues. You need instant results, especially for things like theft detection. Edge computing puts the processing power right there, in the store, using, and this is the cool part, AMD's Ryzen embedded 8000 series processors.
Okay, that makes sense. So less lag, faster responses. But what about the generative AI part? I usually associate that with, creating images or text. How does that fit into a checkout system?
That's the really clever part. They're using it for real-time alert generation. So, the system, using computer vision, sees something suspicious. Maybe someone trying to conceal an item. And the general AI, likely a large language model, crafts a concise, understandable alert for store employees. Instead of just a generic beep, you get something like, possible concealment of item X near aisle 3.
Wow, that's specific. And it avoids that awkward situation where security has to review tons of footage trying to figure out what triggered the alarm. It's almost like having a superpowered security guard, but it's AI.
Precisely. And these AMD processors, they're not just your standard CPUs. They've got GPUs and, get this, NPUs, neural processing units. It's like having a specialized brain just for AI tasks, all working together. This is where MulticoreWare's expertise really shines. They're optimizing all these different AI models to run simultaneously, handling things like product identification and, of course, that theft detection.
So it's not just one AI doing everything, it's a team of AI models working together. I can see how that would make it more efficient and accurate. It's kind of like how different parts of our brain handle different tasks.
Great analogy. I was just reading about their approach, and they're talking about dynamic resource allocation. Basically, the system is smart enough to figure out which part of the processor, CPU, GPU, or NPU, is best suited for a particular task at any given moment. It's all about efficiency and speed.
Okay, I'm starting to see the bigger picture here. This isn't just about catching shoplifters. It's about making the whole checkout process smoother, faster, and probably more accurate. Fewer mistakes, shorter lines. I'm all for that.
Right, and from a business perspective, reduced theft translates to, well, more profits. But there are also ethical considerations. We're talking about real-time monitoring, constant surveillance. There's always a balance to be struck between security and privacy.
That's a really important point, and one we should probably explore further. How do they address those privacy concerns? Are there safeguards in place to prevent misuse of this technology? I'm thinking about things like data anonymization, making sure individual shoppers aren't being tracked or profiled in a way that violates their privacy.
That's something I'd need to dig into a little more. I know there's mention of adhering to privacy regulations, and the quote from Yingyu Xia of AMD mentioned something about homomorphic encryption allows aggregating biometric hashes sans raw PII, which, I admit, makes me feel better. It means they are focused on security.
Homomorphic encryption? Okay, you've lost me again. Explain that like I'm 5.
Haha, okay. Imagine you have a locked box with a secret message inside. Homomorphic encryption lets you perform calculations on the message without unlocking the box, so you can analyze the data without ever actually seeing the sensitive information itself.
That's surprisingly elegant. So they can analyze patterns and detect anomalies without ever accessing personally identifiable information. Clever. But what about the future? Where do you see this technology going in the next few years?
I think this is just the beginning. We're going to see more and more AI moving to the edge, not just in retail, but in all sorts of industries. Think about self-driving cars, smart factories, anywhere you need fast, localized decision-making. And with processors getting more powerful and AI models getting more sophisticated, the possibilities are, well, pretty limitless.
It's a little bit exciting and a little bit scary at the same time. The potential for good is enormous, but we also need to be mindful of the ethical implications and make sure we're using this technology responsibly. It's a conversation we'll definitely need to keep having.
Couldn't agree more. And that's what makes this field so fascinating. It's constantly evolving, constantly challenging us to think about the future and our place in it. But for now, I think we've given our listeners a good overview of this exciting development. Thanks for joining me on this deep dive, Jenny.
Thanks, Mark. Always a pleasure exploring these tech frontiers with you. And to our listeners, thanks for tuning in. We'll be back next week with another episode.